Welcome to Exterior Angle Theorem. Right, so this is actually going to be a fairly short lesson. We're going to look at what an exterior angle is. We're actually going to prove an exterior angle theorem, and then we'll do one problem. So exterior angle theorem, the measure of an exterior angle of a triangle, it is the sum of the measures of the two remote interior angles. And you're probably listening to that going, I don't understand. That's a lot of words, right? So let's break it down. Remote interior. So, you know, when you're at home and you want to watch something on TV and you're not next to the TV and you don't feel like getting up and being next to the TV, you might grab the remote and turn on the TV. Well, remote is not next to the TV, right? It does it from a distance. Well, that's the same thing with remote angles. They're not next to our exterior angle. They're the other angles. They're across the triangle, right? So here, angle one, any day now, and angle 2 are remote interior angles. Right? They are angles inside the triangle, and they're not adjacent to the exterior angle. And we know that we can draw 3 exterior angles, right? One at each vertex. We saw that in the last podcast. So, but it says the exterior angle. It's whatever exterior angle we're interested in. So in this case, we're interested in angle 4. Angle 1 and angle 2 are the remote interior angles. So what this whole sentence up here means is that the measure of the exterior angle, which is angle 4, is equal to the sum of the measures of the two remote interior angles. In other words, angles 1 plus angle 2. So now we have another way to find the measures of angles in a triangle. All you have to do is identify the 2 angles that aren't next to your exterior angle. All right, so now let's actually prove that to be true. Right? And we're going to do that on the next page, and you have this in your notes. And you have this slide in your notes as well, or most of it anyway. So exterior angle theorem, the measure of an exterior angle of a triangle is equal to the sum of the measures of the 2 non-adjacent angles. So we're given a given triangle ABC with exterior angle 4. Okay? Got to have a triangle, right, to prove anything about a triangle. And if we want to prove something about an exterior angle, we better have an exterior angle, right? So we want to prove that angle 4 equals angle 1 plus angle 2. And that's what exterior angle theorem says. So we're going to prove exterior angle theorem. All right, so our proof, you have this in your notes, and I probably typed the word statements and reasons, but I didn't do that in mine. Maybe I'll do it later. So the first thing I should say is that we have a triangle. Otherwise, I'm not going to be allowed to use any of the properties of triangles. So triangle ABC with exterior angle 4. Okay? And hopefully you all realize that that was just given. It's right next to the words given. I didn't figure that out. Somebody told me. Now look at your diagram there. I'm hoping you notice some things that we could say. I'm hoping you notice some of the relationships between the angles. Perhaps you notice that angle 1 plus angle 2 plus angle 3. Oops, angle, not angles equals. Angle 3. What happened to my 3? There we go. Equals 180 degrees. Make sure by the way, make sure you're filling this along with me. Why do we know that? Well, we just proved that in the last podcast. I hope you didn't forget triangle sum theorem. That's what triangle sum theorem says, that you add up the angles in a triangle and they add to 180 degrees. Do you see any other relationships between those angles? I hope you notice this one. I hope you notice that angle 3 plus angle 4 is equal to 180 degrees. And why is that true? Hopefully you realize that they form a straight angle, a straight line, which means that angle 3 and angle 4 are linear pair angles. So we know that the definition of the linear pair angle property is that 2 adjacent angles that form a straight line add to 180. You can either say that, or you can just say linear pair angle property, because that's the second part is just the definition of that. Or you can say linear pair angles add to 180. That's also fine. All right, so now I kind of notice that something is the same in my 2 statements there. All right, about 3 statements there, and 2 of them have something the same. Notice that angle 1 plus angle 2 plus angle 3 equals 180, and angle 3 plus angle 4 equals 180. we have two things that are equal to the same thing. Well, the only way that could be true is if they're equal to one another. Right? And what property is that? That's the transitive property. So all I noticed is repeating things. We had two equations that were both equal to 180. I got two angle 3's in my equation here. You know, I don't think I really need them. I think I'm just perfectly fine saying angle 1 plus angle 2 equals angle 4. Now, why can I go from angle 1 plus angle 2 plus angle 3 equals angle 3 plus angle 4? Well, if you have the same thing on both sides, you do this all the time when you solve an equation. If I have the same thing on both sides, well, you can just subtract out that amount from both sides. That's the subtraction property. All we did is we subtracted angle 3 from both sides. Right? Subtraction property doesn't delineate what you can add, what you can subtract. You can subtract anything you want. And I'll actually write that in so you can see. All we did here is I subtracted an angle 3 here, and I subtracted an angle 3 here. And look at that. We have now proven the exterior angle theorem. And make sure that's in your notes. Make sure you understand this proof, because who knows, maybe somebody will ask you to prove it or ask you to explain it. All right, so I think before I leave you all, let's solve one problem using the theorem that we just proved. Let's use it over here. All right, and this one's in your notes. We're given angle in triangle PQR. Don't know what happened to the little triangle symbol, but here we go. Measure of angle Q is 45 degrees. We can see that in the diagram. Measure of angle R is 72 degrees. You can see it in the diagram. We want to find the measure of angle P. Now we could do it the hard way that we've been doing it and find this angle and then realize that this angle and this angle add to 180, and then we could subtract question mark from 180 to get our angle, or we could do it the easy way. I have a feeling you want to do it the easy way. So using our exterior angle theorem, we can say that that angle x there is equal to the sum of the two remote interior angles, and that would be angle R and angle Q. So that means that x there, which is angle TPR, I added a T there, so I have a way to name it, is equal to 72 plus 45. Isn't that easy? I don't have to find for some other angle. 117 degrees. Okay? And we get the same thing if I added them up and subtracted from 180. Actually, if I added them up and subtracted from 180, I'd get 117, right? And so 180 minus 117 is going to give us 63 degrees, right? And then 180 minus 63 is, oh, look at that, 117. So all that work finding question mark there, right, which turns out to be 63 degrees, when I could just add up those two remote interior angles and find out the measure of the angle without finding question mark. So pretty cool, huh? Well, that's the end of this podcast, and then tomorrow we're going to solve some problems involving triangle sum theorem. See you in class. Bye-bye.